Welcome to the Science 1 class. In this video, we are going to learn about extractive metallurgy of copper. The metal copper will be found both in free state and combined state. The important ores of copper are copper pyrites, CuFeS2, cuprite, Cu2O, and copper glands, Cu2S. The chief ore of copper is copper pyrites. So, mostly the metal copper is extracted from copper pyrites. Now, let's see how copper is extracted from copper pyrites. This extraction involves 5 main steps. They are concentration, roasting, smelting, besmerization, and refining. Let's learn in detail about each steps. First step, concentration or ore separation. Copper ore is separated by froth flotation process. In the previous video, we have already learnt about the froth flotation process. So, copper pyrite is separated by froth flotation process. Second step is roasting. Roasting is heating the ore in the presence of oxygen and while heating the volatile impurities, that is, impurities that can be vaporized, and also the moisture will be removed. So, here sulfur, phosphorus, arsenic and antimony will be present in the ore in the form of oxides. And all these oxides will be removed as volatile impurities. The remaining ore will be in the form of copper sulfide and iron sulfide. The equation is CuFeS2, that is copper pyrite ore, plus oxygen, O2. On heating, we will be getting Cu2S, copper sulfide, and Fes, iron sulfide, along with sulfur dioxide gas. The third step is smelting. In this step, copper sulfide, Cu2S, and iron sulfide, Fes, are dropped into a blast furnace. The image of the blast furnace is shown here. Along with the sulfides, powdered coke and sand ore are added and heated in the blast furnace. On heating, we will be getting matte. Copper sulfide and iron sulfide in the combined form. Along with the matte, slag will be obtained and slag will be removed as waste. The fourth step is besmerization. The matte which we obtained in the smelting process, that is combined form of copper sulfide and ferrous sulfide, is dropped into the Bessemer converter. The image of the Bessemer converter is shown here and the product named blister copper will be obtained. Matte contains 2 sulfides, ferrous sulfide and copper sulfide. So, when ferrous sulfide combines with oxygen and burn, it gets converted to ferrous oxide, FeO. The equation is Fes, ferrous sulfide plus O2 oxygen will give FeO, ferrous oxide, plus SO2, sulfur dioxide gas. Then ferrous oxide FeO will react with silica. Inside the Bessemer converter, silica will be added because it's a flux material. So, when ferrous oxide FeO reacts with silica SiO2, we'll be getting iron silicate FeSiO3. Now, let's see the reaction of copper sulfide. Copper sulfide CuS combines with oxygen O2 to give copper oxide Cu2O along with sulfur dioxide gas SiO2. This copper oxide Cu2O when added to copper sulfide Cu2S, we'll be getting blister copper and sulfur dioxide gas. Blister copper is nothing but 98% pure copper. Blister copper contains 98% pure copper and 2% of impurities. The fifth step is refining by electrolysis. We know that for electrolysis, we require a cathode, anode and electrolyte. Here, pure copper metal will act as cathode. Impure copper metal, that is blister copper obtained in the Bessemerization, will act as anode. And copper sulfate solution with sulfuric acid will be the electrolyte solution. When electric current passes through the electrolyte solution, pure copper will be deposited at the cathode and impurities will be deposited at the bottom of the anode as a sludge. Wet mud is referred as sludge. Hence, sludge is called as anode mud and that can be removed easily. So, this is how copper is extracted from its ore, copper pyrites. Next, we shall learn about the physical properties of copper. You know that copper is a reddish brown metal with high luster, that is more shiny appearance, and has high melting point, 1356 degrees Celsius. We learned that aluminium has melting point of only 660 degrees Celsius. Now, we shall learn about the chemical properties of copper. Action of air and moisture. In the presence of carbon dioxide and moisture, copper gets covered with the green layer, that is copper carbonate. The equation is copper Cu plus oxygen O2 plus carbon dioxide CO2 plus water H2O will give basic copper carbonate, that is CuOH twice CuCO3, which is green. Action of heat. In the presence of oxygen, copper when heated below 1370 Kelvin, it gets converted to black cupric oxide. The equation is copper Cu plus oxygen O2 when heated below 1370 Kelvin will give cupric oxide CuO. Copper when heated above 1370 Kelvin in the presence of oxygen, it gets converted to red cuprous oxide. The equation is copper Cu plus oxygen O2 when heated above 1370 Kelvin will give cuprous oxide Cu2O. Action of acids. With dilute hydrochloric acid and sulfuric acid, no reaction will take place in the absence of air. But in the presence of air, copper gets dissolved in these acids. With dilute HCl, the equation is copper Cu plus hydrochloric acid HCl plus oxygen O2 gives copper chloride CuCl2 plus water H2O. With dilute H2SO4, that is sulfuric acid, the equation is copper Cu plus sulfuric acid H2SO4 plus oxygen O2 gives CuSO4, copper sulfate plus water H2O. Reaction with concentrated nitric acid and concentrated sulfuric acid. Copper reacts with concentrated nitric acid HNO3 will liberate nitrogen dioxide gas NO2. The equation is copper Cu plus concentrated nitric acid HNO3 gives copper 2 nitrate CuNO3 twice plus nitrogen dioxide gas NO2 plus water H2O. Copper reacts with concentrated sulfuric acid H2SO4 will liberate sulfur dioxide gas SO2. The equation is copper Cu plus concentrated sulfuric acid H2SO4 gives copper 2 sulfate CuSO4 plus sulfur dioxide gas SO2 plus water H2O. Action of chlorine. Chlorine reacts with copper resulting in the formation of copper chloride. The equation is copper Cu plus chlorine Cl2 gives copper 2 chloride CuCl2. Action of alkalis. Copper will not react with alkalis. Uses of copper. It is used for making electric cables and electric appliances. It is also used for making utensils, containers, calorimeters, coins, etc. It is used in electroplating. So, electroplating is a process of depositing a layer of a metal on a metallic or a non-metallic electrode. It is alloyed, that is mixed with gold and silver for making coins and jewelry. Okay students, that's all for today's class. In this video, we have learnt about extraction, physical properties, chemical properties and uses of copper. Thank you, students. Have a good day.